Welcome back, Hampshire Chemistry students. In today's video, we're going to be taking a look at trying to identify a saturated and unsaturated solutions from a solubility curve graph. And so we're going to be using a bunch of new vocab here together today. So let's make sure that we're all feeling confident and understand the vocab that we're looking at. I have 6 main vocab terms that I want to run through here together, starting first with the most basic, and that is the idea of a solution. A solution is created very simply when a solute is dissolved by a solvent. Now, hopefully your first questions there are, what are the next two then? These hopefully come from middle school, but a solute is any substance that is currently trying to be dissolved. Usually it's going to be some type of ionic compound or solid. Okay? So examples could be things like NaCl, sugar, or Kool-Aid powder. Now you can't get crazy and dissolve things like gas. That's how they create carbonation. The bubbles in your soda are a dissolved solute of carbon dioxide. Now the solvent does the job here of working with the solute to dissolve it. Okay, so it's a substance that does the dissolving. Okay, our most common solvent is definitely going to be water. Okay, water is going to be used in lots of different solutions and used very commonly. You sometimes can see alcohol, especially in organic chemistry, but we don't talk about that too much. Okay. Now, 2 terms here that come along with solution, solute, and solvent are the idea of saturated versus unsaturated. Okay. If I hear the word saturated, I'm thinking about something that is full. Okay. Something that is entirely filled up. It's a solution that cannot dissolve any more solute. So as some snow melts over the weekend and you go walking down your street, your shoes can get saturated full of water. So we're going to be talking about a solution that cannot dissolve anymore, whereas a unsaturated would be the opposite. It's a solution that can dissolve more. So we have all these vocab terms, and our last one here is a very simple idea of a solubility curve. So a solubility curve compares 2 things. It compares the temperature of a solution and the amount of solute that is trying to dissolve. So we're going to be looking at some different examples here today about how we can read and understand these. But these are our main vocab terms for today. Okay. Let's make sure that we understand them moving forward. And let's take a look then at a solubility curve. Now, solubility curves, in this case, this is for the chemical potassium nitrate, KNO3. And you can see we have those 2 variables that I mentioned. We have a temperature on the x-axis and the grams of solute that are trying to be dissolved. Right? So this line here represents the point at which we would expect to be saturated in our solution. So you'll notice that as the temperature increases, we can expect to be able to dissolve more and more potassium nitrate. Most chemicals like this will increase their amount they can dissolve by increasing their temperature. Right? Think about like a Kool-Aid solution or a hot cocoa solution, right? As you heat something up, it becomes easier to dissolve more and more of a substance. Now, let's say that I was trying to dissolve some KNO3. Let's say I had 40 grams of KNO3, and I don't know, I was at 50 degrees Celsius. I would just play a little bit of battleship here and mark a point like here on the graph. You'll notice that this line is below the amount that is saturated. So we would consider an idea at this point unsaturated. So 40 grams at 50 degrees could dissolve more. In fact, it could dissolve all the way up to about 90 grams of solute. Right? So the graph is very straightforward. Now the last part here, though, does end up being things like supersaturated and something we'll talk more about coming up soon, a supersaturated solution. So let's say I had 130 grams trying to dissolve that at 50 degrees. We could still only dissolve the 90 grams. So what we have here is a difference. It's kind of, again, thinking back to like hot cocoa, if I add more cocoa powder or more Kool-Aid powder to my drink, I'm usually not able to dissolve everything. You'll expect to see a bunch of little bits left at the bottom, more things that can be dissolved. Okay? So we would expect to still be saturated unless you follow some very specific steps to become supersaturated. Now, this is a very simple graph. Let's take a look at a more complex one. Okay? The ones that get a little bit trickier tend to involve more substances. So you can see we have several lines on this graph, including our original KNO3, the light blue line here, but lots of others that are involved. So we can take a look at some example problems with this to make sure we understand how this graph is used. And we can start out with a very simple problem, like what is the solubility of sodium nitrate at 40 degrees Celsius? Well, first off, we got to figure out that that's going to be NaNO3. So when I look on my graph here, I'm going to look for the NaNO3 line. That is my red line here. And it says, what is the solubility at 40 degrees Celsius? So I'm going to go from 40 degrees Celsius up to the point on the red line. For me, that looks like it's about between 100 and 110. So I would say about 105 grams can be dissolved at that point. Now, number 2 then talks about at what temperature are potassium chlorate and sodium chloride equally soluble. So let's find those two lines. I see sodium chloride is just my plain black line here. And potassium chlorate, that is going to be, my dark green line. So I'm going to look to where these two graphs are equally soluble, where they could dissolve the same. So I'm going to look for where they meet right here. Going down from the temperature, I would say that's about 38 degrees Celsius. If you read this graph and said, I don't know, 37 or even 39, I would say that those are all fair estimates of our answer here. So, question number 3. From what you can see here, what substances can you assume has the largest increase in solubility from 0 to 100? So, looking at the 0 all the way to 100, I'm looking for the one that changes the most. To me, the line that stands out as changing the most is definitely going to be the KNO3. You can see it starts at 15 and goes all the way up to 150, even way before it gets to 100. So we could expect that it's maybe hitting something like, I don't know, like 200, 220 grams of solute dissolved at 100 degrees. Other big ones that change, obviously, the sodium nitrate also changes a lot, but I can see the slope is a lot steeper with the KNO3. So I see that KNO3 changes most. So far, we've just been basically reading our graph and not using much of our vocab here. As we move into questions like number 4, you can see that it says you place 70 grams of KNO3 in 100 grams of water. You'll notice that this solution tells me we are dissolving in 100 grams of water, so I actually don't even really need to worry about this in my problem. But because I have the 70 grams of KNO3 dissolved at 60 degrees Celsius, and I want to figure out, do I have an unsaturated or a saturated solution? So let's read this on our graph. I go to 70 grams on my y-axis and 60 degrees on my x-axis. I'm going to see where they meet. I can see that I am at a point right here. This is for number 4. To me, like we just talked about before, we want to think back to our graph. If you are on the line, you are saturated. If you're under the line, you're unsaturated. And if you're above the line, you're most likely going to be saturated as well. So I can see that definitely we are well below our saturated line. So this tells me we have an unsaturated solution. And we are below the line. So let's take a look at our last two problems. It says we place 40 grams of NaCl in 100 grams of water. Again, I'm not going to worry about how much water I have. The graph already told me. At 90 degrees Celsius, and we stir for a long time. So let's take a look here. 40 grams, 90 degrees Celsius. To me, right here for number 5, this looks like we are directly on our line here, telling me that this is going to be a saturated solution. Okay. We are on the line. So, finally, we have our 6th question here. This is going to be our most complex. It says we have a saturated solution of NH4Cl is made at 80 degrees Celsius. So NH4Cl, that is my purple line here. If we're saturated at 80 degrees, that means that we are going to be at around, I would say, somewhere around 68 grams here. So this is going to be 68 grams. And we're then cooled to 70 degrees. So let's see, 70 degrees. I would say that's right at about 60 or so. So 70 degrees is at about 60 grams. So the most I can dissolve at 80 is 68. The most I can dissolve at 70 is 60. And then it asks, how many grams of solid will precipitate out of solution? So this is the word we talked about a little bit, but basically precipitate just means that the solution is, the solid is going to fall down and no longer be dissolved, kind of like rain precipitating, falling down out of a cloud. Now, we can see our two amounts here, that we can hold 68 here and only hold 60. The difference is what I would expect to see drop down. So I figure out my answer here by taking 68 grams minus 60 grams, and that means I would have a difference of 8 grams that would precipitate out. So that is our setup here. You just want to read your graph carefully, make sure you're keeping track of your vocab and how we would use any graph like this one. I hope you guys have a good one and have a great day.